Hello again and welcome back to CCCS121 Programming 2. Um, so I want to add something to our coverage of abstract classes. This topic today is going to teach you two things. Basically, this is an application of an abstract class, Java's calendar class specifically. And it's also going to give you another tool when you have to work with timestamps and dates, calendars in general. So if you take a look at this slide, we have two classes in this UML class diagram. We have an abstract class called calendar, and we know it's abstract again because the name of the class appears in italics. It has a couple of get and set methods. It has a get actual maximum. The description of these methods is given to the right of each method. We have an add method, which is interesting. Adds or subtracts the specified amount of time to a given calendar field, and get time returns the date that is stored in the calendar object, and set time. However, uh, because this is an abstract class, you cannot create an object of this class, and instead we'll have to create objects of any concrete subclasses of this class. And one of those subclasses is the Gregorian calendar. And this is actually, we'll actually kind of be using both. The Gregorian calendar class, you can see, is on its face not very interesting by itself because it only has three constructor methods shown over here. So there's a bunch of ways you can create a Gregorian calendar object and initialize it. But after that, if you want to manipulate or even just view any of the contents, the data contents of a calendar object, you will be reverting to the methods that you're inheriting from the abstract calendar class. Now, before I move on and before we do a coding example, one thing you have to understand is that time for computers is counted in milliseconds. So computers don't measure the passage of time or record the passage of time in seconds, minutes, hours, um, days, months, and years. Instead, for computers, or what we also call computer time, or sometimes also called Unix time, time is measured just as milliseconds from a specific date, from this date over here, January 1st, 1970. So about 50 years ago, at midnight GMT, Greenwich Mean Time. So that's time. That's how computers keep track of time. It's just one number in milliseconds. So 1,000 milliseconds in 1 second. Okay. Um, and what obviously that is not convenient for us humans, and that is why we have the calendar class. The calendar class basically converts this time that computers use, computer time or Unix time, in milliseconds since this date. They convert that for our convenience uh, uh, into a time format that is more that we're used to, such as the Gregorian calendar that I'm going to try out. Obviously, there are other calendars in the world. So, for example, uh, uh, the Islamic lunar calendar, there's the Jewish calendar, there can be other calendars, I imagine. Now, all of those calendars, like the Gregorian calendar, will be subclasses of the abstract calendar class. Okay, so they'll be sitting somewhere here in parallel to the Gregorian calendar class down here. Another thing to note is that in the Gregorian calendar class, um, so we specify the year as a number, of course, and the number is the same as the year. Uh, the count of months, however, starts at 0, meaning that January, being the first month, in the Gregorian calendar is assigned the number 0. It's the first month of the year, but it is assigned the number 0 because, again, uh, counting starts at 0 in all respectable programming languages. Um, February becomes month number 1, March becomes month number 2, and so on. Okay, so let me begin with a simple example. We have an empty project. I'm calling this one week underscore 12 underscore 3. This will be uploaded as week 12.3. Okay, so let's begin first by making a calendar object. I'm calling mine cal. Pay attention what I'm doing over here. So I'm going to make this an object of type Gregorian calendar. But over here, the reference will be to calendar, which is fine because Gregorian calendar is just a subclass of calendar. And this way, uh, whenever I have to pass a calendar object somewhere, I can just pass cal as well, so that works fine. Okay, so done. That's it. We have our calendar object cal of type Gregorian calendar specifically. Okay. First of all, let's see what's in this. What's in this object? So system out print line, and just going to. So let me just print out cal. This will automatically print out whatever's produced by the toString method of cal of Gregorian calendar. Let's see if that's useful. And you can see, not very useful. This is printing out first day of the week, minimal days, blah blah blah. So lots of different fields in here. Week of month. We'll get to those. Okay, we'll get to those in a few minutes. Okay. So since this doesn't seem to work so well, the toString method for calendar doesn't seem to work so well. Let's if you want to see the time nicely formatted, we call the getTime method on cal. And this gives me something like this. See, this is much more useful. Monday, November 19th, 12:57, Arab Standard Time 2018. Okay. Now I can also change the time that I'm storing in here in my cal object, and for that I can use the set method. So let's say I want to change the date that I have in here, so I call set and I change it to 2020, the year 2020, the month of 21. Let's say June. June is the 6th month in the calendar, which means month number 5 over here. And let's make it 5th June. So this will be June 5, 2021. And just to see that is actually the case, let me print out cal.getTime again. There you go. June 5, 2021. And I did not mess with the time, so the time is still the same. 12 o'clock, 58 minutes and 30 seconds. Okay. What else? Yes, then I can also set a new date and time using using the set time method. Go back over here. We had a set time method in the calendar class. I can also use that. You can see that this one takes a date object as argument. Okay. So let me just jump back here. java.util.date. This is the one we've used before. New java.util.date. There you go. Got that. And yes, now let me make a call to cal's set time method and pass it the date object I created up here, and let me just print it out over here and see what I have in here again. So this should, when I create the date object over here, this will be the date and time right now. So this will put the date of time of right now back into cal. So I changed it from the time now to 2021, and now I'm changing it back to the time now. I run this, there you go. So it was Monday, November 19th, 2018, then it became June 5th, 2021, and that changed it back to November 19, 2018 again. I could have done that also using the set method, but I'm just showing you what the set time method does. Instead of giving these numbers, the date and the date figures like this as numbers, you can just use the date. Instead of hard coding them, I can just pass an entire date object like so. Okay. Now we saw in the call to the toString method of the Gregorian calendar class that there were lots of different fields, member variables inside the Gregorian calendar class. We saw year, month, date, hour of day, minute, second, day of week, so Sunday, Monday, Tuesday, day of month, um, day of year. So how many days has it been in the year today? Week of month. How many week in this month are we in right now? Week of the year, AM PM. So the difference between hour and hour of day is hour is when the way when hours are counted from 1 to 12, and we start again afternoon. We start again at 1. That'll be the hour, 12-hour notation. Hour of day is we have 24 hours in the day, and this is the notation where we go at afternoon time. We go from 12 to 13, 14, 15 o'clock. 13, 14, 1500 hours. So if you're using the 12-hour notation, you'll need to know whether the time is AM or PM. So AM, PM, you have to use that together with hour in order to know what time exactly you're talking about. Okay, let me go back here and let's try out some of these fields. Let's try to access some of these fields. So let me see. Yes, so what we'll basically be demonstrating is the get method up here. We'll be getting the value stored in one of these fields at a time. So for example, the hour field, the year field, and we'll be using the get method, and in the argument you have to provide which field, you have to say which field you want. Now you'll see that over here it's asking us for each of these fields is addressed as an integer. Okay. Now it'll be quite difficult to remember which of these fields is represented by what integer number. Luckily, we don't have to remember any such thing. Instead, what we can do is this. The calendar class actually has some variables mapped to these numbers, so we can just use those variables. It's actually quite simple. So let me demonstrate system. So we'll be doing a whole lot of printing now, and let's say I want to print out the year value. So So I'm going to call cal.get, and over here I have to provide the integer value that maps to the year field inside the calendar class. Now instead of remembering or finding out what that value is, I can just simply say java.util.Calendar and look here. So here are a bunch of variables that are declared public, static, final integers that store, that map those numbers for us. So I want the year, so I can just look up over here. You see there's lots of these. Year. Just select year. There you go. And if I run this will print out the year value stored in the cal object, which is 2018 at the moment. There you see, year equal to 2018. Now, if you find that this is a little too long to type, especially if you have to do it many times, we can now do something. We can simply import the calendar class like this here at the top. And now, let me keep this like this, and let me do another one. Let me do dot month. Let me print out the month value next. But instead of typing this whole thing here, I can just say calendar.month, because the Java compiler will now know what which calendar class I'm talking about, because I've imported it up here. I can do that with other classes as well. I could do that with the date class that we're using down here. I can do that with that as well. So let me run this. Month 10, because it's November. November is the 11th month of the year, which means the assigned integer in the calendar class is 1 less than that, 10. There's a whole bunch I can try out actually. So let's just go through that whole list that we had in the table. So we had month, we had date, we had, let's see, what else did we have? We had day underscore of underscore month. We had day of week. We had day of year. We have hour of day, which is the hour in 24-hour format. We have just hour, which is the hour in 12-hour format. We have right next to that AM PM, which you need in the 12-hour format. Next we have minute. We have second. And we have, let's see, we had week, of year, week of year. We have week of month, week of month. And another interesting one, we had one called zone offset. This is kind of interesting, this one. Zone offset. Let me run this one. Let me run these. Okay. All right, so that's the old stuff at the top that we already did. So year, 2018, month, 10. We check those. Today is the 19th day of the month, 19. Day of month, it's the 19th day of the month. Day of the week, 2. Today is, so I guess the new week starts on Saturday. So Saturday is 0, Sunday 1, Monday 2. Day of year, 323rd day of the year. Hour of day, this is the 13th hour. It's 1 o'clock 10 minutes right now, the 13th hour. Hour, just 1, because it's in the PM. AM is 0, PM is 1. Minute, 10 minutes. Seconds, see up here, 24 seconds. It's the 47th week of the year. It's the 4th week in this month. And here's the last one, zone offset. It's a very big number. So this is basically the offset, the time you have to add to, or the number of milliseconds that we are ahead or behind GMT. Okay. So if you want to make sure, so we are at 3 hours plus GMT. If you want to convert this, so let's say the zone offset. So this one was the zone offset. Let me format this a little bit, space, zone offset in milliseconds. Okay. And now let me print that out again, but this time let me divide the number by 1000. That will convert the milliseconds, count number of milliseconds into the number of seconds. And let me divide it by 60. That will convert the number of seconds into, that will give me the number of minutes. And if I divide by 60 again, that will give me the number of hours, because there's 60 minutes in an hour, right? And to make this clear, in hours. So this will convert the zone offset number into hours. Oops. Let's miss something. Oh yeah. Parentheses aren't closed. Same problem over here. It's too much. Now again, try this. There you go. So the zone offset remains the same in milliseconds. And when I convert this number from milliseconds to hours, I get 3. And Arab Standard Time is 3 hours ahead of GMT. So I think that's all we need to know about the calendar class in Java. And this is well, before the second midterm exam, we are also going to do interfaces and the numbers class. So we'll do that. We'll do that next.